Today is going to be another one of those brief lectures. Just covering the units that you use in engineering and that sort of thing, the metric units. Start with the basic. Meters for distance. I believe the definition of a meter is something along the lines of 2.99 times 10 to the 8th power of the distance that light travels in 1 second in a vacuum, or something like that. But a meter is about 1.1 yards, or what is that, 39 inches-ish. For those of you used to the American way of measuring things. Time is measured in seconds. Again, I believe it's how many times a particular atom vibrates, or how much time it takes a type of atom to vibrate a certain number of times is the definition of a second. Liters for volume. A liter is 10 centimeters, a cube 10 centimeters on either side. Let's see here. And then when getting into electrical engineering, you have volts. Potential difference. Also the pressure that the electrons have between 2 points. That is the difference in electrical potential. Amps. Which is a measure of current. One amp is quite a bit, so most of the time you use fractions of an amp, like a milliamp or microamps. Resistance is in ohms. Ohms, and Ohm's law are related to voltage and amperage. We'll get to that when we get to resistors in the electronic components section of this semester. Farads is a measurement of capacitance. A farad is quite a large quantity. Capacitors will be often measured in microfarads or picofarads. We'll get to those prefixes momentarily. Henries is a measure of inductance. What inductance is, we will get into when we get to the inductor topic in the electronic components section of the class. But they are the inductor is characterized by how many henries of inductance it has. With the volts and amps, you have watts. That's a measure of power. Like the charger on the wall here for that this fellow's using is probably a 12 or 20 watt power supply. So it supplies that much power. What other ones do we have? Oh, and when you get into signals, you use hertz, which is a measure of frequency. There's a bunch of other metric units that for measuring all different types of things, but these are the primary ones that you use in engineering. Oh, well, I guess first some you get degrees Celsius for temperature. For other types of engineering, you don't. You might run into this in temperature of components when they're dissipating so much power, or the temperature of a soldering iron that you're using to assemble a circuit. That just about sums up the metric units. The prefixes we have, because you don't always deal with the large units that the standard units that were just up on the board. So you use prefixes to shrink or enlarge them. Deci is 1/10. and you get, I believe, blood is measured in deciliters, tenths of a liter. Centi, which is 1/100th. Like a centimeter is 1/100th of a meter. Actually, the definition of an inch is actually 2.54 centimeters. So while we use inches, it's technically it's defined by the metric system. Milli is 1/1000th, like a milliwatt or a milliamp, millivolt, for small quantities in that area. Micro, which is 1/1,000,000th. Again, microfarads are a common unit used for capacitors, at least the kind of capacitors that you can pick up. A multifarad capacitor would be too heavy for you to pick up. They're that large. When you get onto the manufacturing side of electronics, you will run into nanometers. Silicon chips are typically manufactured at where a transistor would measure between 7 and 14 nanometers across. The time it takes for a signal to go from a input to an output of a logic gate is measured in nanoseconds, 1/1000th of a second. Pretty snappy. And then finally, the only example I have of pico, which is 1/1,000,000,000th. Yeah, 1/1,000,000,000th is the picofarad for a small decoupling capacitor that is used in timing circuits. Those capacitors are typically measured in picofarads. On the other side of things, there's little used, but for sake of completeness, deca, which is times 10. I was not able to think of a example of the use of the deca prefix. And likewise, the hecto is times 100. Again, very rarely used. Couldn't find a reasonable example of its use. So there you go. It's a not very commonly used. Then you have the more commonly used kilo times 1,000. Kilogram, which is about 2.2 pounds. The kilometer, which is 1.6 kilometers is equal to a mile, give or take. Mega, times 1 million. The measurement of atomic weapons is for large atomic weapons is in megatons of TNT equivalent. So 1 million tons of TNT going kablooey is the equivalent of a nuclear explosion. Giga, times 1 billion. You might have heard of power stations generating gigawatts of power. Yeah, it's a good amount of power that generates cities, parts of states, counties, that sort of thing. Then you have the tera. One 1 trillion. Most hard drives that you get nowadays are in the terabyte range, trillions of bytes, as opposed to just 40 years ago when I had my first computer. The first computer with a hard drive was only 256 megabytes. Now they're in the terabyte range. So come a long way as far as memory is concerned. And then for supercomputers, you will run into the peta prefix. One quadrillion. Supercomputers run at speeds of multiple petaflops. Flops is a acronym for floating point operations per second. So how many times can it crunch numbers per second? It's in the quadrillions of calculations per second that some supercomputers can perform those operations. The prefixes do get smaller and they do get larger, but for practical purposes, these are the ones that you're going to need for engineering. But let's see here. Any questions about these, or no? Pretty simple and straightforward. Just memorizing the powers of 10. And the units will get more in detail on some of those when we get to the electronic components section of this course, which should be next week, starting next week. So we're going to have a quiz on this sort of this stuff, this material, and last Wednesday's material. Just a 10-question quiz. If you took notes and were paying attention, you should be able to finish it in about 5 minutes. But we'll have a quiz, and then we'll start into basic electronic components. Like I said, this is a brief lecture today. So go ahead and have a wonderful evening. See you Wednesday. Again, quiz, in person, on paper, open notes, no computers. Yes, notes have to be printed if you want to use them. Wednesday.